Okay, so for the remaining 30 minutes for this lecture, I'll be talking about the tidyverse. So I think for today we can only cover the very first part of the tidyverse that I want to introduce you the idea of the tidy data and what's the advantage of having your data set tidy. Okay, so we're essentially using the same data set from the case study that we just discussed. And the test for the case study, number one, again, we want to do the normalization of feature intensity in the sense that after the normalization, the median of log2 intensity stay equal across from. And second test, since we have two data sets from DIA in the SRM. So once we normalize the data and we can do the protein level summarization for each protein, and then we can compare the protein abundance or protein summarized intensity between the two data sets and to see how much agreement we get from their quantification result. And like I say, we'll discuss the tool in the tidyverse to address this task, and in particular, how to tidy out the messy data set and also do some manipulation and transformation during the data wrangling, and how to carry out the split apply combine approach that we discussed briefly in the previous lecture, and also how to join data set in a consistent fashion. So when you load the tidyverse data set, it's essentially a collection of multiple R package, multiple library. And when you load this chord library, that would give you a 6-chord package, ggplot2, tbow, tidr, readr, per, and the dplyr. So the main focus that, when I plan for this lecture, I want to focus more on the tidr and the dplyr. And so since we have some requests for the how to read data, so tomorrow morning, before the regular schedule, 8 o'clock. So I can also talk about some aspect of the readr. Okay, so like I say, the tidyverse is actually a collection of multiple R packages that they share common representation and also the design philosophy. It's designed to make your data analysis easier. And so we'll mainly talk about tidr and dplyr during the regular section. But however, there are also other packages that you may find useful. For example, there's one called stringr for analysis or operation of string, and also one called the Broom package that you can actually tidy the model object in a very consistent or clean manner. Remember, in the last two tests from the previous section, we actually have some hard time how to decide, so how to actually to manipulate those model objects from the LM modeling and also from the t-test. Okay, so from now, load the data set, load the library. And before we get started, so there are some quite helpful convention for data wrangling that I want to tell you about. So the first thing is, so in this twin DIA, it's a data frame. And in tidyverse, tbow is a form of the data structure that most or all the packages in tidyverse rely on. And you can use this as tbow function to create a tbow from an existing data frame. So what's tbow? Essentially, is still a special type of data frame, but by adding some additional type, that actually give us some slightly give us some difference in some aspects. So the very first one would be the printing. For a table, actually, when you can actually, when you print this object, it only shows the some of the most important part from this object without eating out all the space of your console. So for example, if you go back to this original one, and if you hit enter, that's going to eat out all the space of your console. That I'm not going to do that here. And another thing is, if you remember when we do the subsetting, table and data frame actually have slightly different property. So for example, here in this table, I say I want to get the first column, and I'll return another table still, and with the whole observation and everything in this variable. However, if I do something slightly different, I convert this one back to data frame and subset for the first column. First show part of the result. It actually gives us the vector, not the data frame. The string vector. So in many analysis texts, sometimes the confusion or the issue come out because we are not quite sure each of the operation or function how they coerce the result. So for example, here we just want to do some subtyping, subsetting. However, the type of object actually changed already. Okay. As we mentioned, you can use this view function to call the data field in RStudio. And another important thing I want to introduce is the pi operator. It consists of three characters, percentage greater than and percentage here. And what the pi operator here is, so here, for example, when we do a function call here, x and y, that would, an equivalent representation with the pi operator would be, we are going to operate on this x object, and we'll pass this x object to the function, to this particular function, with some additional argument with y here. And you can actually train multiple operators here. So here, for example, we want to train f1 and f2. And you may remember in previous section, in Baser, actually this kind of representation is nested. So if we want to interpret or understand the meaning of this code, we need to read from the inner part of the code all the way to the outer part. However, with the chain operator, actually the workflow becomes much clearer. So we know we want to operate on this x object with this function 1. And after that, we'll pass on the result, the output of the function 1 to the function 2. And because it's used very, very frequently in Tidyverse, and in RStudio, there's a keyboard shortcut that I found very convenient to use. So in Mac, you can use Command plus Shift and M, and in Windows, you Control Shift M. That would, so for example here, that would actually give you the pi operator right away. Okay, now I want to talk about the tidy data. So first, let's think about what's a tidy data. So in a tidy data set, the definition for a tidy data set is, in this data set, each variable should be saved in its own column in the data frame, and each observation should be saved in its own row. And in a single table or data frame, that consists the same type of observational units. And why we want to have the tidy data? Because tidy data actually make the factorized operation in R very straightforward to apply. So you can actually, let's look at this one. So you can actually assess any of the variable very easily, and you can apply those variable on with some operation or with some simple operator, for example, plus or minus. And now, okay, I talk about the definition of tidy data and what really a tidy data is. So let's look at some example and to see what's so-called tidy and what's the untidy or messy data. And here I'll just run some code to make some messy data. And essentially, I take a subset of the original data set with 2 proteins and 3 runs, R001, 2, and 3. Okay, so one way of the representation would be I save the intensity from the heavy channel in one table, in this table, where the last 3 column has all the intensity value for the heavy channel in round 1, round 2, and the round 3. And I have another table for the light channel, again, round 1, round 2, round 3. Okay, now just look at one of them. Let's think about whether it's tidy data. Any thought on that? Now the definition, one of the definition of tidy data is each row represents one observation. Now, is it one observation? It's actually the feature intensity in 3 runs. And similarly, so each of the row actually is the feature intensity in 3 runs. And actually, one of the variables that should account for the run ID is stored in the row name here. So this R1, R2, and R3, they should be a variable to represent the run ID that we can link to those intensity value. So it's not ID. Another example. This one. So here, each row actually is the intensity for one of the 2 channels, either heavy channel or light channel. So do you think it's tidy? Let me make a poll. So for those of you who feel, okay, the sub-2 here is tidy, raise your hand. It's tidy? Yeah. And it's non-tidy? Yeah, so I think I take both of the opinion, I would say. I think for, that's it. I think for sub 2, people may have quite different opinion whether it is tidy or not. And really based on the basic unit of the analysis that you think in your workflow. People may say, okay, it's tidy. If you actually view a feature in a channel from a run, it's a basic unit for the operation, then it's tidy. However, if you actually view a feature from one run should be the basic unit of your operation, then it's non-tidy. You should actually have 2 columns to restore the intensity from light and channel. Yeah, so I think both interpretation is okay, I would say, but in this section, I will take a second view. So I would say for this representation, I would prefer to have 2 columns for the intensity, one for the heavy channel and the other for the light channel. That's correct. Yeah. Right. So the question was, so if we want to use ggplot to plot the data set, so for example, if we want to use a ggplot, and actually the representation of the sub 2 actually would be very natural to make this title plot, because for each observation, actually we can use a label column to link together to their where they come from, whether they are from the heavy peptide or the light peptide. So it will be very natural to make this title plot. Okay, but here just remember we'll take the second view, and so I will introduce the tool in Tidyr, so how to convert or transform between those representation, and you can actually based on your analysis workflow to decide what's your basic analysis and what should be the tidy format in your workflow. And the third one, I'll just show here. The third one, we have one column called intensity both that shows both the intensity for heavy and the light channel. And I think right now you all agree it's non-tidy, because you have two value restored in one column, and also the title of the variable is incorrect. It's restored as a string. So if we want to tidy this data set, we need to separate up those 2 values and convert it back to the correct type of the variable. Okay, now let's talk about what's the tool available in Tidyr that we can use to reshape the layout of the tabular data set. The first one is called gather. The gather function is to gather multiple columns into a key value pair. So for example, here in the first data set, we have 3 runs. We have the intensity value from the 3 runs restored in 3 columns. And so how to tidy them? We actually need to move the column name R001, 2, and 3 into a key column to essentially to restore the run ID, and then to gather the value from the 3 columns into a single value column. So to call this gather function, we need to first pass on the data we want to operate on, and then define the name for the key column that I'll call it as run to restore the run ID. And also another column for the value column, that's for the intensity H heavy. And from which I should gather the value of intensity. They are from 3 columns, R0, 0, 1, 2, and 3. So that's the original representation. Sometimes people call it as a Y format. And now we gather those intensity into this new column and with one additional key column called round. And we talk about the pi operator that you can actually use in this way. So here we want to operate on this sub 1a table, and then we pass it over to the gather function and with some additional argument defined inside it. So that would essentially give us the same result as the previous one. Okay, now what we can do for the sub 1a and 1b, they actually restore for both heavy and the light intensity. So we can use the same approach to tidy each of them, and then we combine the result. And I'll use a function called left join that we'll introduce later on. But essentially, that combine the tidy 1a with the column for the heavy channel and 1b for the light channel. That essentially would match based on the column name. That's essentially the same as the merge function that we introduced in the previous section. Okay, now let's move on to the next one, the sub2. That for this one, we actually want to spread. The value in this intensity column into 2 columns, one for heavy and one for light. So essentially, we move around. We move the unique value in the label column into the column name, 2 column name, and then we spread the value from this intensity column to the value for those 2 columns. And the syntax is very similar. So we want to operate on the sub 2, and with the key here from the label column and the value from the intensity column. So that actually spread the value from this one and to 2 new columns, and the column name from this key, either heavy or light. And just to make sure everybody get familiar with and be comfortable with the pi operator, we can pass this object to this spread function with the argument defined here. Okay, and in some case, we actually have a mix of both issues. we have the value spread out in the 3 column, and also we have variable spread across row, one for heavy and one for light. So we actually need to have both spread and gather function to take care of this kind of situation. So in this case, we'll first do a gather to gather the value from the last 3 columns into a single column called intensity, and then we'll spread it into 2 additional columns. So let's do it step by step. We'll first do it. We'll first gather the 3 columns, and now we have a new column called run and new column called intensity. However, we still need to take care of this situation, so we need to spread the intensity value here into a two new column with a key defined in the label column. So that will essentially be here. We'll first do a gather and then spread. And after that, I will again use a function from dplyr to rename the column name, the heavy into the intensity H, and light into the intensity light. Okay, that would essentially give us the format that we want to work on in the case study. The label, run, and intensity. Okay, now to take care of the very last one, we need to have a way to separate this column into 2, because in this column it actually contains 2 variables, one for heavy and one for light. So we can use the separate function by defining what's the column you want to separate on and into which column, and then define a string separator. One thing you may notice that is, so after we separate this one into the 2, and you see the title variable is still the character, because originally it's stored in the character format. So one thing you can do is to pass on one additional option that tell this separate function trying to convert the type of the variable after the separation to the simplest possible format, and in this case you get to the integer. Okay, so very similarly, we can actually, again, in addition to separate the very last column, the intensity, both into H and L, and we can separate the feature into maybe more meaningful annotation as a peptide, Z1 fragment, and Z3. And the very last thing I want to talk about, so again, you comes in the opposite direction of the separate. We can separate one column into multiple columns, and we can also combine or unite to merge multiple columns into one single column. Again, by defining what the separator should look like. So here, I do the same thing. I separate the intensity both into 2 columns and feature into into peptide Z1 fragment and Z3. And you may want to combine 3 of them as a new column co-transition. So you can do that with essentially the very similar syntax to the separate. What's the name for the new column is co-transition. And from the 3 columns, Z1 fragment and Z3, and with the separator underscore. That will be the new representation of your data. So I think that will be all for this section. So we cover the tidy data and the tidyr in the tidyverse. And tomorrow we'll be talking about the dplyr, how to do the data manipulation and transformation, and also more about how to do the modeling with some other technique like PER and also the nested data frame. So any question, I can answer quickly.
All right, we're going to take a quick 5-minute break, and then in 5 minutes at 5:05,